Okay, can you just note your answer to that? Okay, when rearranging formulas or using formulas, we don't like using an image like this, but we do like using a formula. We don't like the image because it carries no proper meaning, whereas the formula has a universal mathematical meaning. We all know that this means the distance divided by the time will give us the speed. This one, you cannot derive it from an intuitive understanding of speed, whereas almost all of us can use an example to generate the formula, i.e. 120 miles in 2 hours would be 60 miles an hour, so it's the distance divided by the time gives us the speed. This way, the image doesn't encourage and support good mathematical understanding, whereas this way all of us can help support and encourage and use mathematical thinking. We'll look at an example now. So I've got speed equals distance divided by time, and we can all work that out. Any idiot could work that out by doing the 120 miles in 2 hours is 60 miles an hour. So we can work out, if we want to work out the distance, we divide it by the time, and it gives us the speed. If we know the speed, we can undo the operation. The opposite of dividing by the time will be timesing by the time, or multiplying by the time, which will give us the distance. So we now know that speed multiplied by time will equal the distance, or S times T equals D, or ST equals D. And we can use an example to show that. For example, 60 miles in 3 hours, so we would divide by 3, equals 20 miles per hour. And I'm doing that, 20 miles per hour, and the opposite of divide by 3 is multiply by 3. So 20 miles an hour for 3 hours would of course give us a distance of 60 miles. We could use it in another case, the same idea of this undoing technique. We sometimes call it a machine chain rule. If I've got V equals U plus AT, I can pick any one of these. I'm going to pick the T and say that T, the time, times by the acceleration, plus U, which is the initial speed or initial velocity, will be equal to the final velocity. If I wanted to find out what the time was, given the other three, I could start with the V, subtract the U, because the opposite of adding the U is to subtract the U, and the opposite or inverse of timesing by A is dividing by A, and I've now got V minus U divided by A will equal T, and I can write that down as V minus U divided by A equals T. we could check that out with a numeric example. So I'm going to use t. Let's say we have t is 10 times that by acceleration. I've chosen 9.8, acceleration due to gravity, an initial speed of 2, and that should give us a velocity of 100. And we could put that in the formula at the top as well to be sure that's right. We're going to say that 2, which is initial velocity, plus 9.8 times 10, which is of course 98, does actually equal 100. So we can now undo that to show that worked. 100 take away the 2, divide by 9.8 should give us, over here, our initial time of 10. 100, take away 2, I often write just here, 98. 98 divided by 9.8 is 10. So I've shown that it works. So, it's really important that we don't use single images or remembered facts, but we help students use general understanding and manipulative methods.